Hello everyone. Thanks for joining us at 2021 Esri Virtual Developer Summit. My name is Jay Zhang, and here with me is my colleague Nirupam Day. We are product engineers from Esri's Imagery development team. In today's workshop, we're going to talk about ArcGIS Online Imagery platform and how you can use the ArcGIS API for Python to perform analysis on the imagery data hosted in ArcGIS Online as a developer. Now, this is the first time we introduce ArcGIS Online Imagery to our users at the conference. Therefore, we are not only going to talk about the API, we'll also give you an overview of the ArcGIS Online Imagery platform and what kind of capabilities you can expect from this new feature. Now, let's jump right into a quick introduction. ArcGIS Online Imagery is basically a new software as a service offerings for imagery data hosting, visualization, exploitation, analysis. User can now bring their own local imagery data, and that Esri hosts those data in ArcGIS Online, and Esri will also provide a rich set of tools for you to perform analysis and visualize those data in ArcGIS Online. And imagery is an important part of our ArcGIS Online platform stories. Therefore, since the ArcGIS Online 8.2 release, we introduced the imagery functionalities to the ArcGIS Online platform. And from the 8.2 to 8.3 release, the ArcGIS Online imagery features are in beta release. Only the organizations that participate in the early adopter program will receive invitation and join us in the testing of this new feature. And if you are from one of those organizations, here we thank you for your participation and your feedbacks to this new functionality. And in the 9.1 ArcGIS Online release, the imagery capability will become generally available to all the organizations in ArcGIS Online. But the dynamic imagery layer capability will stay in the early adopter programs. And as a ArcGIS Online imagery user, you don't need to worry about the maintenance for your, you maintain your own premise enterprise in the servers. ArcGIS Online, Esri will take care of it for you. And we'll make sure the server is scalable and the imagery layer and the analysis you want to perform on those layers can perform well. Now let's have a quick overview of the ArcGIS Online Imagery's capabilities. To the left, you can use the ArcGIS Online Imagery capability to host imagery data. What it's referring to is the users will have ability to upload imagery data and create imagery layers in the ArcGIS Online organization where you have the imagery capability enabled. And the hosted imagery capability also supports management of a collection of imagery data. And like in ArcGIS Pro, we also support many different raster types, which referring to different type of raster data that support in the ArcGIS ecosystems. There are over 30 different raster types that is supported in the ArcGIS Online hosted imagery capability. And once you are able to create those imagery layers, you can visualize them in ArcGIS Online's web map. And we have also enhanced our web map, the JavaScript API, to support the client-side imagery layer renderings. And there's also, and meanwhile, you also maintain the capability to perform server-side dynamic renderings if you decide to publish a imagery layer that has those features. And we also enhance our client to utilize the tile API for the imagery layers to even improve the rendering speed on the web map. And eventually you want to perform analysis. You may want to perform analysis on your imagery data. Similarly to other ArcGIS Online, other ArcGIS products, we also introduce a rich set of raster functions, over 160 different raster functions that you can use to perform analysis on your imagery data. And there's also over 18 out-of-the-box analytic tools you can use, including deep learning analysis tools for you to perform analysis on these imagery layers. And with raster functions, you can customize and share those custom-made workflows as items in your organization with other users. Now, if your organization decides to sign up for the imagery capability, the organization administrator will be able to grant permissions to the organization users by assigning privileges through the member role settings. And there are several essential capabilities that we introduce when we release the ArcGIS Online Imagery. You'll be able to see them under the contents privilege group and also under the premium contents privilege group. These privileges allows the organization administrator to control whether the user will be able to create hosted tile imagery layers or hosted dynamic imagery layers, and whether you will allow your user to perform imagery analysis on those imagery layers. And because some of these imagery analysis workflows may also produce hosted feature output, sometimes you will also need to enable the publish hosted feature layer privileges for the user if you want them to be able to perform analysis. Now let's look at the first capability that ArcGIS Online Imagery provides to our users, which is the Create Imagery Layer capability. Right? The Create Imagery Layer item is supported now once your user has the required privilege enabled. And the users, when the users come into their contents page and expand the Create option, they will see this new Create Imagery Layer options from the menu, from the drop-down menu. And this option basically supports your users to upload local imagery data and to create different type of imagery layers. And by clicking on that option, expand it and bring up the Create Imagery Layers wizard. And under this wizard, there are two different types of imagery layers you can create by uploading your local data. There is tile imagery layer type, and there is a dynamic imagery layer type. Please be aware that dynamic imagery layer will still stay in early adopter programs in this 9.1 ArcGIS Online release. And under both layer type creation workflows, and you have the option to decide on how you want to create those layers. For the tile imagery layer and dynamic imagery layers, you can either simply publish one, upload the image, or you can publish a collection of imageries. And when you are publishing a collection of imagery, you can either choose to mosaic the entire collection to a single imagery and then publish that imagery as an imagery layer, or you can publish the collection separately as separate layers. One add-on capability that was offered by Dynamic Imagery Layer is the dynamic mosaicing capability. If you choose this mode to create a dynamic image layer, behind the scene, we'll be creating a mosaic dataset hosted in ArcGIS Online's enterprise database, and then use the mosaic dataset to manage the collection of imagery data you uploaded to ArcGIS Online. And with that mosaic dataset, the dynamic image layer has the ability to produce dynamic mosaicing and view to your image collection, and also allows additional functionalities such as querying and filtering. Now I want to quickly compare the difference between these three different type of layers, these two different type of layers, and the tile imagery layers that you may already be familiar with if you are a ArcGIS Online users. So basically, if you have used tile image layer before, you will know that the tile image layer essentially is a tile cache based of data set that static dataset that only supports 1 or 3 band JPEG PNG tiles. And it is good for visualization, but there's no ability for you to perform the server-side processings. Now with the new imagery capability, you can create tile imagery layer and dynamic imagery layer. And the difference between these two types of layers are based on the functionality these two layers offers. For the tile imagery layers, the data that the tile imagery layer refers to is actually this cloud raster format raster dataset. When you create the tile image layers, there is also no image server behind ArcGIS Online to support this type of data, the cloud raster format data. But we provide a lightweight tile handler to respond to the clients, similar to tile layer to respond to a client's rendering requests. And although tile image layer does not support server-side dynamic processing and image access, and it's also a static tiles, but the cloud raster format, this special type of format, is actually a fully functional image information models. What it means is it can support beyond 1 band or 3 band imagery data, image tiles. It can also support different pixel types and even multidimensional data. And therefore, tile image layer has the advantage of tile layer. It's good for visualization, and it can also be used for analysis as the input for your analysis workflow. And on the other side, when you create dynamic imagery layers, the data it referenced to could be a cloud raster dataset format, or it could be a mosaic dataset that we use to manage the collection of image data you upload. Therefore, and also the dynamic image layer actually has a ArcGIS server running behind the scene to support the server-side dynamic processings and server-side dynamic mosaicings and imagery query and access. Therefore, the dynamic image layer is also good for visualization if it also referenced the CIF raster dataset, and it also provides additional capability that allows the user to perform dynamic mosaicing and processing on the server side. And it can also be used as the input for your analysis workflows. So when you're asking yourself whether you want to create a tile image layer or a dynamic image layer, based on the functionality difference provided by these two types of layers, you can decide what kind of functionality you need, and then decide on which type of layers you want to create. And we also provide ability for you to convert existing tile image layers to dynamic image layer, or vice versa, republishing a dynamic image layer as the tile image layers. Now there's a few additional points I want to mention in the create image layer workflows. So when you are publishing image data to ArcGIS Online, all the data you uploaded will be converted to the cloud raster format based on the different creation mode you chose, except when you choose the imagery collection mode to create a dynamic image layer, we will create the hosted mosaic dataset behind the scene in the enterprise database hosting ArcGIS Online, and then reference the original uploaded imagery data in their original format. And when you are publishing cloud raster format based imagery layers, either it's dynamic or tile imagery layers, the tile API is enabled automatically by default at the service endpoint. Therefore, the client can utilize this API to support optimized rendering. And there's also additional capability we provide is to allow users to create a new dynamic imagery layer to manage existing tile image layers they have created earlier in the organization. Now let's move on, and I'll hand it over to my colleague Nirupam, and he will give you a couple of demos about how to use the create image layer user experience to create the image layer from your uploaded imagery data.
Thank you, Jay. Hello, everyone. In this first demo, I'm going to go over how to create imagery layers in ArcGIS Online. As mentioned earlier, an user with appropriate privileges enabled would be able to see Create and Imagery Layer option under the content page. This option allows users to upload local data and create imagery layers. Once you click on this option, it opens the Create Imagery Layer wizard. At first, you have to choose the type of layer you want to create. As explained earlier by Jay, you can choose the tiled imagery layer or dynamic imagery layer based on your requirement. Both these layer types are good for visualization and analysis. Let's go over the tiled imagery layer option. Once you click Next, you can create a tiled imagery layer from a single image, or you can create a mosaic from a collection of imagery by mosaicing all of them together into one single raster dataset. Or if you want, you can create one single imagery layer for each of the images you have uploaded by selecting this multiple layer option. Now let's go over the one image. Under this define imagery section, you will notice that the raster type is set as raster dataset. And under configure properties, you can define the source type. It can be generic, elevation, thematic, or processed. This is based on the type of data you want to publish. And under compression, you can select the compression type that you want and the compression error. In addition to this, you can select the metadata and provide acquisition date or measure a unit of the pixel values or perform custom band mapping. Once everything is defined according to your need, you can click apply and the settings are applied. To upload the data, you can click on browse and select the data that you want to upload. If you want to remove any data from this list, you have to click on the data and click remove. You can also drag and drop your data to this location and it will start the upload process. And you don't have to wait for the upload to complete. Rather, you can fill up this item details and then click on create and the layer creation process will start. Now let's look at the other options that we have. For one mosaic option, you can select the different raster types based on the data that you want to publish. Now let's look at the NetCDF. Under configure properties, you can see the source type is scientific and you can provide resampling type and compression as well as the error. Under processing, you can provide a processing templates associated with the NetCDF and provide the special reference and metadata. If you select a satellite raster type and under configure properties, you have to provide the product type that you want to publish. And based on the product type you have chose, there will be a definite set of processing templates that will be available to choose from. Once you select the processing templates, you can apply default stretch, build footprint, or define a no data value. Under more settings, you can customize the way ortho rectification is done and also additional parameters for footprints. And then you can provide the special reference and metadata too. Now let's look at the dynamic imagery layer options. If we go back and select the dynamic imagery layer and unselect tiled imagery layer, click on next. You can create a dynamic imagery layer for a single image, or you can create a mosaic from a collection of imagery by mosaicing all of them together into a single raster data set. Also, you can create an image collection where the server will create a mosaic dataset and reference the collection of imagery you have provided. Or if you want to create a single imagery layer for each of the uploaded data, you can select this multiple imagery layer option. So this is how you can use the create imagery layer wizard in ArcGIS Online. Back to you, Jay.
All right, thanks, Nirupam. Next, what I'd like to cover is the enhancement we made on the web map viewers to support the rendering of tile and dynamic imagery layers after you have created them. Nowadays in ArcGIS Online, we have the classic version of web map viewers implemented using JavaScript 3.x API, and also the new web map viewers that was implemented using 4.x JavaScript API. In both web map viewers, the client has been enhanced to utilize the tile API from the tile and dynamic image layers to achieve the faster imagery rendering. And the scene viewer has also been enhanced to support both type of imagery layers. Now, because the utilization of the tile API, we also provide additional new renders for the tile imagery layers to support the client-side rendering. So what the client-side rendering means is the browser can pre-cache the imagery bundles or image tiles from the layers, and then processing the pixels utilizing client machine's GPU in the browser, and to achieve the even faster rendering results in the browser. And as for dynamic imagery layers, because the dynamic imagery layer was actually supported by an image service hosted in ArcGIS Online, it also supports the custom rendering rules that was submitted from the client. What that means is, if you're familiar with the image service capability in Enterprise, you will know that you can actually create a raster function template and ask the server to process this function template and generate the on-the-fly processing result back to the client. And additionally, you can also have you will also have additional add layer options. For a dynamic image layer, you can either add it as a dynamic image layer while rendering it in the web map, or you can actually add it as a tile image layer if the dynamic image layer was referencing a cloud raster format raster dataset behind. Now, on top of this visualization enhancement, we also provide additional options for the users to configure on their dynamic image layer items. Again, if you're familiar with image service in Enterprise, we also bring in those image service settings to ArcGIS Online as well. Once you create a dynamic image layer items and then go into the item details page, you'll be able to customize the settings through the settings page. You can define, for example, the default rendering rules that which is a function template that attached to the image service. You can decide whether you allow analysis to be performed on the dynamic image layer, or you can define, for example, a default resampling methods. And if your dynamic image layer is actually created through the image collection mode, you will also see additional options on the item detail page under the image management tab to support additional processings on the dynamic image layer, such as build footprint, build overviews, compute sim lines, color correction, stats, or node data. And these options will show up based on the type of data as you publish. And ArcGIS Pro is also enhanced to support working with ArcGIS Online imagery data. When you connect to ArcGIS Online organization that has imagery layers created in the organizations, you can visualize those imagery layers in the ArcGIS Pro map. And the ArcGIS Pro also supports utilization of the tile APIs on the tile and the dynamic imagery layers. And you can also perform image analysis using raster functions from Pro and ask the ArcGIS Online raster analytics servers to perform the analysis. And you can use the ArcGIS Online imagery layers as input, and you can also decide how you want to share the output imagery data back to ArcGIS Online. You can choose either to create a new tile image layers or create a new dynamic imagery layers in ArcGIS Online after the analysis has completed. All right, next I'd like to show you a couple of demos introducing enhancement we made in the web maps for different type of imagery layers for faster visualization, and also additional settings you have access to on the imagery layer items details page. Switching to this map here, I have a few pre-created tile image layer in this organizations. I want to use this tile image layer to introduce a few client-side new imagery layer renders that we introduce in ArcGIS Online. The first layer is this California DM tile imagery. And I can go to the imagery display option from the context menu, and I can choose this new shape relief render. So basically, this shape relief render will perform a hue shade processing on the DM data and apply a color ramp on the processed hue shade pixels. And all this could happen on the client side. All this is actually happening on the client side on the tile that has been already pulled down from the cloud storage. As you can see, the render settings apply very quick, and you can see that the display result is almost instant. And another client-side render I want to show you is this color map render. What I have here is another tile image layer, which is the US land cover dataset. And this dataset has a color map, so I can just go to the imagery display option again and just choose the color map render. And then, as you can see, applying the process of applying the color map on the original image data is also happening on the client side. The third example I'd like to show you is the multidimensional dataset. The tile image layer can also be published from a multidimensional cloud raster format dataset. A multidimensional dataset is basically a time series dataset. You will see additional options when you bring in such layers into the map, where you can have access to the options such as enable time animation or multidimensional filters. If you go into the multidimensional filter, you'll be able to choose which variables you want to display on the layer and which time slices or other dimensions that you want to filters using this additional filtering options. Now, next thing I'd like to show you is the additional options you have access to on dynamic imagery layers. This is a dynamic imagery layer item I created earlier, also from a California DM dataset. And in this imagery layer items, if I go to the settings page, I'll find additional image layer specific options, which allows me to control the request size limit, example count, resampling method, etc. And one capability I want to highlight in this dynamic image layer settings page is the ability to define a raster function template as the processing template of the image service. If you are an enterprise image service user, you will know that you can actually upload one or many raster function template and have it used as the processing template for the service. We also bring in this capability to the ArcGIS Online imagery layers. And if your image layer is created from a image collection from a mosaic dataset, and like this one, the CI's imagery collection dynamic image layers, you'll see the Image Management tab becomes available in the Item Details page. By clicking this tab, based on the data type that you published, it will show you additional processing tools that you can run against the mosaic dataset behind this dynamic image layers, such as build footprint, overview, calculate statistic, and define node data. Now let's look at several dynamic image layers in the web map as well. The first dynamic image layer is the California DM dynamic image layers. As you can see earlier, I actually have defined a processing template with the image service. I can see the additional options showing up here in the imagery display tab. It allows me to choose this additional raster function template defined as the processing template of the dynamic image layer. I can choose it. This template is basically generating the slope map and assign a color map to the slope. I can apply this template. Now the difference between applying a processing template on dynamic image layer and applying a render on the tile image layer is that this processing template, this rendering is actually happening on the server side. So we're actually sending the function template to the image server that is behind the dynamic image layer and ask the server to generate the rendering result back to the client. So this is what the slope map processing template looks like on this DM dataset. Additionally, if the image service itself actually doesn't have a processing template defined, the client can also send the template that is already raster template item that is already exists in this organization as a client renders and ask the server to render it back to you. Again, this imagery is a burn image burn index image that I have created earlier as a dynamic image layers. And when you go into the imagery display tab, under the render options, there's this plus button you can use to add a custom raster function template as the rendering rules for this dynamic image service. I can choose this remap NBR, the normalized burn ratio index function template, and ask the server to render it back and display on the client side. Now again, this rendering is happened on the server side, and then the only difference is the template itself was not defined as part of the dynamic image layer settings. So any user can actually, if they have the permission to use your image service, they can actually add a custom raster function template as additional rendering rules to the dynamic image layer and have the server process the template and return to the client. Now, one last dynamic image layer example I'd like to show you is the image collection example. In this case, I've created and I've uploaded a collection of RGB imagery that is covering the LA downtown, and I choose the image collection mode to create this dynamic image layer. Therefore, I have access to the tables behind this dynamic image layers. There's actually a mosaic dataset created in the enterprise database hosting ArcGIS Online and show you all these individual imagery items and dynamically mosaic them together and display it on the map. Okay, so this is a quick demo on how the enhancements we made to render the tile image layer and dynamic image layer in web map, and also additional options you have in the dynamic image layers item page. Coming back, now we have covered the visualization of the image layer. Next, what we want to talk about is the imagery analysis. As I mentioned in the introduction at the beginning, the ArcGIS Online Imagery capability includes the imagery analysis support for the imagery data. We provide 18 different ready-to-use tools under the analysis pane in the ArcGIS Online's web map that allows you to perform additional analysis on the dynamic and tile imagery layers. And as of the 9.1 release, it also includes the deep learning inferencing tools. And the deep learning tools running ArcGIS Online will by default using the GPUs to achieve the fast processing result. And we also have over 160 different raster functions that you can access through the raster function editor user experience. If you are familiar with the enterprise raster analytic capability, you'll also know that you can launch this raster function template editor from the analysis pane. Through this user experience, you can combine and chain multiple raster functions together to create a custom analysis workflows. And it works with both tile image layer and dynamic image layer as input. And when you are performing analysis, you can choose either to generate the output raster data as a new tile image layer or a new dynamic image layers. And when you are performing analysis, each analysis operation actually will cost credits. So you have these additional options to estimate how much it's going to cost you to run a certain analysis workflows. And we also have this. We also provide the ArcGIS API for Python to support running imagery analysis on ArcGIS Online. And ArcGIS API for Python, the ArcGIS module, actually is a very powerful API that supports the entire workflow that I mentioned from the beginning. It supports the create imagery layer workflow, and it can also visualize the imagery layers in ArcGIS Notebook. And you can also create and edit raster function template for the on-the-fly processing result. And you can also perform image analysis to generate the persistent imagery layers as a tile image layer or dynamic image layers. So Neropon will show you a demo on how to utilize all these APIs to automate all these workflows. And ArcGIS Online now also has hosted notebook capability that allows you to author your ArcGIS Python API workflows within the notebook. And it actually provides up-to-date ArcGIS Python API for image analysis. So the analysis result can also be shared as directly as shared as hosted feature layers or image layers out of box. In this particular examples, you can perform deep learning object detection analysis using the tile image layer or dynamic image layer as input, and then output a feature class that is on the coconut tree found within the image. Now next I will hand it over to Neropon, and he will show you a series of demos of utilizing ArcGIS API for Python to perform analysis on ArcGIS Online.
Thank you, Jay. In this part of the demo, I will show 4 examples of using the ArcGIS API for Python with ArcGIS Online. In this, I will be showing publishing imagery to ArcGIS Online, performing raster analysis, multidimensional analysis, and then deep learning object detection. And due to time constraint, I'll be going over the examples quickly. In this first example, I will show how to utilize the copy raster and create image collection functions to upload and create tiled imagery layers and dynamic imagery layers. First, we are importing the necessary libraries and then providing the login information and then creating a GIS object. Now to create one image imagery layer, I am using copy raster function, and for input I am giving a path to a local dataset. Then the output name and raster type name is provided. This tiles only parameter determines whether you are creating a tile imagery layer or dynamic imagery layer. If this is set as true, then this process will create as tiled imagery layer. And if it set as false, it will create a dynamic imagery layer. Once this function is run, it will upload the data to ArcGIS Online and an imagery layer will be created. Here I am accessing the output that was created and then displaying it using the web map widget. Now to create one mosaic imagery layer, in this I am using copy raster function, and for input I am giving a folder path to a set of netcdf files. Note that for raster type I have provided netcdf. Also, since this is publishing a netcdf data and I want to retain the multidimensional information, I am setting process as multidimensional as true. Then by setting the tiles only parameter as true, this will create a tiled imagery layer. Now let's access the imagery layer and display it. Since this is a multidimensional imagery layer, we can access the multidimensional information from the imagery layer object itself. Here you can see the multidimensional info like the variables, statistics, and others. Now for creating an image collection imagery layer, create image collection function needs to be used. And for input, I am giving a folder path to a Sentinel data. Note that for raster type name, Sentinel2 is provided. And since we have additional settings for the raster type, we are providing as in the raster type parameters. And for footprint and build overview, we can provide that as part of the context parameter. And since the tile only is set as false, this process will create a dynamic imagery layer. Using these steps, you can upload local data to ArcGIS Online and create imagery layers. In this second example, I will show how to build a raster function chain and apply a raster analytics job from ArcGIS API for Python to ArcGIS Online Imagery. As shown in previous example, we are importing the necessary libraries, providing the login information, and we are creating a GIS object. In this example, we are calculating the terrain ruggedness index on a digital elevation model data that is already published to the ArcGIS Online Imagery. Terrain ruggedness index expresses the amount of elevation differences between adjacent cells of a DEM. To calculate the terrain ruggedness index, we will use the focal statistics, which performs a neighborhood operation. First, we will access the imagery layer on which we want to calculate the terrain ruggedness index and displaying the layer on the web map widget. Then to calculate the terrain ruggedness index, we will follow this model. First, we will utilize the raster calculator to calculate the terrain ruggedness index using this formula. And then we will apply the remap and color map for better visualization. Whenever we are applying the functions locally, it is generating the in-memory outputs which you can visualize. To generate a percentage output, you have to submit the raster analytics job to a server, in this case ArcGIS Online Imagery. Here we are applying the functions to the output of the previous functions, using which we are building a raster function chain. And here we are accessing the raster analysis output and displaying it to the Finger Lakes region. In the third example, we will show how to perform trend analysis on a multidimensional imagery on ArcGIS Online using ArcGIS API for Python. As shown in the previous example, we are importing the necessary libraries, providing the login information, and then creating a GIS object. I have pre-published the nightlight data. This consists of nightlight data since 1992. Here we are searching for the layer and creating imagery layer object and then displaying the imagery layer on the web map widget. So here we have zoomed to a Texas state for visualization. And since this is a multidimensional data, if we want to access the multidimensional information, we can do it by calling the multidimensional info. This information tells us the variable names, dimension, extent, and others. The values here, it represents the milliseconds from epoch. It represents year 1992 to year 2012. To perform the trend analysis, we have selected time dimension and gave the variable name. For trend line, there are three options: linear, harmonic, and polynomial. We are selecting the linear model to fit the nightlight data. And for model statistics, we are selecting the p-value of slope. Here we are accessing the linear model output coefficients and displaying it in the web map widget. This map of trend model output doesn't seem to be too intuitive. So we are going to apply another function called trend to RGB. It is to visualize the model coefficients. In this preview, the increased trend is represented by red and decreased trend by blue. Red areas indicate the urbanization of those areas. And then to save this output as a persistent imagery layer, we can call the save option, and it will submit the job to the ArcGIS Online Imagery to create the imagery layer of this output. In the fourth example, we will show how to perform a deep learning object detection workflow from ArcGIS API for Python to ArcGIS Online Imagery. As shown in a previous example, let's import the libraries, then provide the login information, and then create a GIS object. For deep learning on imagery, there are four key categories: pixel classification, object detection, instance segmentation, and object classification. We are going to look at object detection example. In this example, a deep learning model has already been created as a DLPK file, which is a deep learning package file, and it contains the model definition file. This DLPK file is already uploaded to ArcGIS Online account, and imagery layer is already published to the ArcGIS Online organization. Here I am accessing the DLPK file, and to learn more about the model, you can utilize the query info option. Using this, we can identify the parameters we have to provide in the following steps. Then I am retrieving the imagery layer information on which I'll be applying the object detection and displaying it on the web map widget. To apply the object detection, we will utilize the detect object function from learn module and provide the input raster, model object, model arguments, and output name. Here I am accessing the output feature layer and then displaying both the input raster and output feature layer to see how the coconut trees are detected. These are the four examples for today's demo. Back to you, Jay.
Thanks, Nirupam, for the Python API demo. Now, before we move on to live Q&A sessions, I'd like to briefly go through the cost metering aspect of ArcGIS Online Imagery. For the imagery storage cost, the tile image layer and dynamic image layer are computed differently. The cost for tile image layer is calculated based on the imagery files you uploaded to ArcGIS Online storage. And while for dynamic image layers, there is a cost for uploaded imagery files, but also on top of that, additional cost is calculated based on the number of imagery items was referenced by every layers. And organization admin can monitor the credit cost through the organization dashboard, and there will be a new imagery storage item that brings more details to the organization admin. And the user can also find those size information and count information from every imagery layer's item details page. For the image analysis job, the cost is dependent on many different factors, like the type of analysis tools or functions, the number of pixels processed, number of feature processed, and number of bands and dimension slices are also taken into account, as well as the complexity of function templates, if the analysis was performed by a raster function chain. And the same as storage cost, organization admin can access the detailed credit cost information from the organization dashboard as well. Now, if you're still a ArcGIS Online Imagery Early Adopter Program participant, our EAP site will still be available after our ArcGIS Online 9.1 release, which is in March this year. And you still have access to documentation, forum, and we welcome you to report issues if you come across any and send some suggestions to us. And at the point of this video's recording, we're still working on ArcGIS Online 9.1 release. So for all of you who are not EAP program participants, please stay tuned for more information when we have the ArcGIS Online 9.1 release. All right, thank you very much for your interest in our workshops. Please provide your feedback for this session by filling in this session surveys. Now we can move on to the live Q&A session.
Hi, everybody. Thanks so much for coming to our presentation. I'm Julia Lenhart. I'm a product engineer on the raster team. I will be moderating the questions today. We're just going to get started with some of the more popular ones that came in. Let's start with Chris's question. What are some of the noteworthy differences between Image Server and the new ArcGIS image for ArcGIS Online in regards to tools and functions, or why you would choose one over the other? Jay, do you want to start?
Yeah, I can actually expand a little bit on that. So if you're going through the presentation that I show, the biggest difference between Image Server and ArcGIS Online Imagery is one is this enterprise solution where you can set up your a server and host your imagery on premise, right? The other one is the SaaS offering that the backend environment is hosting ArcGIS Online. The other noteworthy difference in terms of functionality is there's two types of image layer you can create using ArcGIS Online. One is tile image layer and dynamic image layer. While with the enterprise image server, there's only one option, which is the dynamic image server option, right? In terms of analytic functionalities and tools, they are actually 99% the same between image servers, the things supported by image servers and by ArcGIS Online. You have access to the full library of raster functions that you will see in you see that can be supported by image server for dynamic rendering and perform raster analytic analysis, and all those building analysis tools as well.
Great.
Yeah.
And I just want to remind everybody we have a poll live right now. So if you want to go ahead and answer that question, and if you have additional questions, just put them in the Q&A and we'll make sure to get to them if possible. So Nirupam, can you publish imagery layers to ArcGIS Online from ArcGIS Pro? And is it a similar process when publishing feature layers?
Yes, we are working on Wizard, like a UI Wizard for publishing from Pro to ArcGIS Online. It will have the same configuration how we demoed in the web UI, and also all the configuration parameters, raster types will be included from the Pro also. The UI publishing will be a little bit different than the feature layers because this is we are trying to have a dedicated publishing experience for publishing to ArcGIS Online.
Awesome. Thank you. And it looks like a lot of you are interested in deep learning. Sorry, I'm switching between screens here to look at questions. So one of the questions that we saw was, will the pre-trained deep learning models be available in Image Server? And then I'm just going to tack onto that, since a couple of people were asking, when will deep learning tools be available in ArcGIS Image for ArcGIS Online? So let's start with the first one. Will pre-trained models be available in ArcGIS Image Server? Jay, do you want to take that one?
Sure. So the ArcGIS imagery for ArcGIS Online release, when it becomes a release offerings to you, will not contain those will not contain those pre-trained deep learning models for different type of workflows, right? What that means is you won't be able to directly see it from your content page once you enable the ArcGIS imagery for ArcGIS Online capability. But we do offer and publish over a dozen pre-trained deep learning models through our Living Atlas, through our ArcGIS Online content page. Right? We can share a link later on to you, to all of you who are interested in exploring those ready-to-use pre-trained models. And those pre-trained models can be downloaded from Living Atlas, and then you can reshare those models into your organization, which has the ArcGIS Online capability enabled, and then use those training models, pre-trained models, to perform inferencing on your hosted imagery data.
Great. And keep the questions coming, everybody. If you have any other questions about ArcGIS Image for ArcGIS Online, one thing that came up a few times in the Q&A is about downloading capabilities. So does one of you want to talk about whether downloading from ArcGIS Image, once you have published hosted tiled layers, can you download them?
I think I can take this one. So the general download capability, the download capability is actually different, has different meanings for tile imagery layer and dynamic image layers. If you have a tile imagery layer published through this ArcGIS Online capability, there's no user experience directly, you would be able to right click on an image layer in your web map and say download. There's no user experience for that kind of workflow currently in ArcGIS Online with the imagery capability. But you can utilize our API to actually to utilize the service API to actually clip out the portion of the imagery and save it to your client apps. If you have if you're working on some custom maps to interact with tile imagery layers, and for dynamic imagery layer, the download can also mean that you have a collection of imagery and you create a dynamic image layer referencing the original format of those of those imagery files hosted in ArcGIS, and you want to download those original imagery files. And that capability is again still at work at the moment, and we don't have that in the current ArcGIS Online imagery release. So, but it is in our roadmap. Eventually, the functionality for both tile image layer and the dynamic image layer to support download will be available. So just stay tuned, and we'll have it available later on.
And Nirupam, so what's the credit cost system? What is the basis for charging credits on imagery storage and on analysis?
So the credit cost system is based on storage, like how much the size of the imagery data that has been used, or the data that has been uploaded and stored as hosted imagery. And for the analysis part, it's based on which image service and how big is the data, and based on that, and also the processing that you will be performing. So based on those criteria, the storage and analysis costs are determined.
And the question everyone wants to know, when will this be available? Jay, I'm going to let you take that one.
Okay. So although in the slides we mentioned that there will be a March release, but the release date was actually pushed. We'll still be in beta after this April ArcGIS Online release. There's no fixed date yet for the final release for this ArcGIS imagery for ArcGIS Online capability, but we'll have more clear answers by time of UC this year.
Great. And there was a follow-up question about the deep learning models. So there's deep learning models in the Living Atlas. The question is, can you use them directly on imagery, or do you have to download them first and then use them? Just looking for clarification on sort of the process of using those pre-trained models.
I can take this one again. So the deep learning model in Living Atlas, you cannot use them directly on ArcGIS Online, right? So it's the contents that for you to download. But once you download it, you can use both use locally in ArcGIS Pro, or if you're a participant of early adopter program for ArcGIS Imagery for ArcGIS Online, you will need to reshare those models you download into your organization, and then you can use against the imagery layers that you have created in your organization.
Great. Well, I think that's all the time we have for this session. Thank you, everybody, so much for joining us today. Thank you, Jay and Nirupam, for a great presentation. And we look forward to getting more feedback from all of you when we release ArcGIS Image for ArcGIS Online. Have a great Dev Summit, everybody.